the cloud. Alrighty. Then welcome everyone to this month's in the May 2025 edition community meeting of Dependency-Track. First, the organizational stuff maybe. The community meetings are recorded and will be uploaded to YouTube as well. The slides will be published to our community repository on GitHub. If you have questions during the presentation, please ask them in the Zoom chat. I hope you can access it. It should be available. If not, maybe one of my teammates can give me a hand. And there will be an open Q&A as always towards the end of the session. Agenda for today, it was like announced in the social media post that we did. During previous meetings, we mostly discussed version 4 of Dependency-Track, releases, new features. We had guest presentations. So this one is entirely dedicated to the upcoming version 5, which we codenamed Hades. Specifically, just a very brief overview over what version 5 even is. Then I will cover a small selection of functional changes that I deemed or we deemed important. There will be a few non-functional changes that are good to know about. There will be notes for contributors and also a small, like tiny section about what's next. In general, I'm very looking forward to your feedback on this. I try to strike a balance between giving a broader overview and making it kind of technical, so it's a little bit more in depth. I would love to hear towards the end from you if it was too technical, if it was not in depth enough, or if it was not technical. Yeah, if it was not technical enough, sorry. So very much looking forward to your feedback on this. Yep, starting out with the overview of what version 5 even is. We codenamed it Hades. It doesn't really have a more like broader meaning behind it. The objectives of this version are enabling Dependency-Track to handle more projects, potentially up until the hundreds of thousands of projects. We want to improve the resiliency of Dependency-Track, so you can have like more confidence if you use it in your workflows, in your CI/CD pipelines, etc. And we want to improve the deployment and configuration experience so it is easier to deploy into production. We also want this to really be the platform that we build more supply chain related features on. For example, CBOM is a topic that is looming over Dependency-Track for a while. Hardware bill of materials, and various more kinds of analyses that you can use to identify risk in your supply chain. The project is currently composed of 3 repositories. One is the main one, just called Hades. Then there's the API server, which is mostly the existing version 4 application, and the Hades front end. So 3 repositories. The issues are managed all in the Hades repository. So if you have any bugs or any feature requests, you would raise them there. For the functional changes, at first, let me cover policies. And we covered this before in an earlier community meeting. We added the capability to use expressions in policies, and we chose the common expression language for a means to define those expressions. Here in the screenshot, you can see I defined an expression or a condition of a policy that checks whether the project in question is tagged with public facing, and if it has at least one vulnerability with severity critical, and or the CVSS version 3 vector matches a given pattern. And the pattern in this case matches on the attack vector being network. This is just a very, very small and contained example of what you could do with these expressions. The editor that you see here is capable of showing errors. So if you have typos or more various kinds of errors I will cover shortly, it will show you where those errors are, and it will also show the kind of error that you're seeing. In this case, I made a typo. I mistyped severity. Behind the scenes, and this is kind of interesting, we could probably have an entire meeting just about how this works, but the entire engine, the entire policy engine has been rewritten to be powered entirely by Cell. The legacy conditions that you can use in Dependency-Track version 4. So for example, you can match in conditions on Perl, on vulnerability severity. All of these things will be transparently converted to cell. You don't have to do anything on this. And they will be executed just like a normal expression condition. The inputs for conditions or for expressions are defined in protobuf. So in the previous screenshot, you saw me accessing a project variable that was available to me and a vulns variable, so the vulnerabilities that affect the project. There's also a component variable. And again, those are defined as protobuf messages, which means we can provide type safety. So if you try to use operators that do, or if you try to use mathematic operators on something that is a string, you will get an error and it won't let you save the condition or the expression. It also means it is easier for us to ensure backward compatibility. So as we evolve this integration, as we add more fields, as we remove fields, we can have, there's very good tooling to detect if something is a breaking change or not. And we use that tooling to catch those things earlier. But what's kind of really cool about this integration is we can hook into the evaluation of those expressions. And we analyze the abstract syntax tree after type checking. So we know what kind of variables are accessed, what fields of those variables, and potentially also of what type those variables are. This allows us to only load the data from the database that is needed to evaluate these expressions. And that is in stark contrast to something like Open Policy Agent, for example, where the OPA service is a separate network service, right? You would have to load all the data that could possibly be accessed, send it over the network, even if the expression only like checks for a name or something. And the more context you want to give, the more data you would have to load. And we can very efficiently avoid this by analyzing the expression and only loading what is needed. We also save on networking overhead, of course, because this is entirely embedded. Cell is also not a scripting language. It just evaluates the true or false. You can't have while loops, you can't have for loops, you can't define functions. It is quite safe to execute due to this as well. So it being restrictive is actually good, both for us and for you as a user. We also extend cell with custom functions that are domain specific. So we allow you to do version checks that are powered by verse. And verse is just a like notation for version ranges. We allow you to do dependency graph traversal. So those are all extensions that we added to cell and that are available to you in policy conditions. Now, after we implemented this for like normal policies, we thought, hey, can we use this somewhere else? And in Dependency-Track version 4, you have this problem where if a vulnerability affects multiple projects and you want to suppress it because maybe it's a false positive, you have to do this on every single project, right? And there's no global setting where you can just say, hey, please suppress this for all the projects. Many tools give you the ability to define a suppression list. Maybe they allow you to match on a certain regular expression for package names or for vulnerability IDs. And that is cool, that is fine. But the auditing workflow in Dependency-Track can do a lot more. It has like basically all the fields that you would have in VEX. It has an analysis status, a justification for your analysis, a details text field. So there's much more that you can do. And just suppressing doesn't really quite cut it in this case. Also, maybe you want to have more flexibility as to when you actually apply such an analysis. So what we ended up doing is we introduced a new concept, which is called vulnerability policies. They reuse the cell expressions that I detailed before. This is just a YAML representation of a policy. You can define multiple conditions. If you define multiple, they all have to match. In this case, I defined only one. And the lower part here, the analysis part, is actually what you would get in a VEX if you like, or what you can see in Dependency-Track in the Audit Vulnerabilities tab. VEX itself doesn't quite cut it for us because VEX doesn't have conditions, right? For VEX to be useful in our use case or for internal vulnerability management use cases, you would have to create a lot of VEX files and import them to a lot of projects. And that doesn't quite scale, for lack of better terms. This is much more convenient to express conditions like this and having them being evaluated in an efficient way. Now the way or the biggest value of this is really when those policies are being evaluated. Here you can see like the basic, very simplified workflow from vulnerability scan results being introduced. I don't know if you can see my mouse if I move it here, but it starts with vulnerability scan results being consumed, parsed, then synchronized with the database. It then invokes the policy evaluator. The policy evaluator evaluates the policies, returns an evaluation result, and then the finding and the analysis result are applied atomically. So if you suppress something, it will not produce any notifications whatsoever, and you get the assurance that your analysis actually gets applied. If there's an error in between, nothing gets applied. I showed you the policy in YAML format, and that is because we decided to implement this first in a code-first approach, so to speak. A common workflow that you would use here is you would use Git server, could be GitHub, where you manage those YAML files. You push your policies, you create a PR, someone else from your team comes along, reviews it, ideally approves it. Your CI server then like packages the policies in a zip or tar archive and pushes it to a blob storage. Could be normal file storage, Nginx, Apache, or S3 or something else. And then Dependency-Track can be configured to regularly check on this file location, pull the policies in, reconcile them internally, and apply them. Just one example how we can do it. We have an example repository on our GitHub. It is public. This is just like plainly putting YAML files in the repository. GitHub then allows you to download a branch as a zip file. You can use this functionality to integrate with this workflow as well. So we call these zip files or tar archives bundles. Once the bundle is synchronized with Dependency-Track, you will see it in the policies view next to the normal policies. Here, just the same representation as in YAML. And we also show you the information about the bundle that we have last synchronized, including when it was created and when it was last synced. And here you can also see I used like a normal GitHub URL that allowed me to download the repository as a zip file. So this works. What's still to be done here? Cell should really be the main way that you define policies. You have seen in the earlier screenshots, it was just a like tiny code editor window. That's not how it should be, in our opinion. It should be the first thing that you see. It should get more space on the UI, and then it should be a central UI element, right? And then the legacy conditions that are currently translated could be offered as templates or examples on the site that you can then pull into the editor window to make your life easier if you don't want to start out with an empty sheet, essentially. The vulnerability policies, I mentioned they are currently kind of in a GitOps workflow or a Git-centric workflow. It would be better if they would be also manageable via the UI. And if you could possibly also scope them to specific projects or make them owned by specific teams. The user experience of authoring expressions is still a bit janky. That kind of has to do with the editor integration, to be honest. So it needs a little bit more work. And we also want to offer autocomplete for fields and functions and variables that you have accessible in the expressions. Moving on to access control. Short refresher as to how access control currently works. You have users. Users can be members of teams. Both users and teams can have permissions assigned. The list or the set of effective permissions is the sum of the permissions assigned to the user and all of the teams the user is member of. And then in order to be able to access a project, the team must be given explicit access permission to a project, which just means that if this relationship doesn't exist, you cannot use or you cannot access the project. Now, this is a preview feature in version 4 still. It still has quite a few gaps, and that kind of largely has to do with technical limitations that make fixing those gaps very expensive, so not really feasible. But we really want to push this feature to production readiness in version 5. We already fixed most known gaps. The biggest part still is that if you can only access or see a limited set of projects, you still see like the portfolio metrics for all the projects, which of course is suboptimal. But filtering down the projects to only those you can see or you have access to is again potentially expensive and needs a little bit more SQL foo actually. But we now also support inheritance, which was a topic we covered for the version 4.13 release meeting, I think, in accompanying the collection project's introduction, right? Inheritance just means that if you have an inheritance tree or a project hierarchy, where in this case, project A is the parent of project B and C, and project B is the parent of project D. If you give access permissions to project A, to a team, the team should also be able to access the other projects, right? And this is not possible in version 4. Again, kind of a technical limitation thing, but in version 5, it now works. And it was actually rather easy to fix now. As for the current status of this, I said we want to have this in a production-ready state. You can follow the current progress on this epic, or like it's a parent issue on GitHub. There are lots of child issues that we are currently working on still, but also those that have already been done. But there's more that we want to do, and that really came out of interactions with the community. We want to make access control more granular. If you use access control and dependency track, you probably wished for this at least once. Just reiterating the current model, there's a portfolio management permission that gives you access to like create, modify, delete, update components, projects, and associated objects. So it's very coarse. And permissions are global, as I have shown in the first entity relationship image. Essentially, permissions are global in the sense that once you have, for example, the portfolio permissions, a portfolio management permission, it applies to all the projects you have access to, which can again be a little bit too coarse for your needs. Also, due to how projects are represented in dependency track, you would have to, or teams have to be assigned to each project version individually, just because project versions are treated as separate projects in dependency track currently. What we want to do better is we want permissions to be more fine-grained. We want it to be possible to scope permissions to specific projects, and we want to allow you to give access to projects to specific users, not only to like broader teams. And also access control should be applicable like to all project versions. For example, if you give access to project Acme app, it should automatically be applicable to all the versions of that project, at least per default, right? You shouldn't have to assign the access every time for every single version. The biggest challenge really is making this perform well. It is quite easy to do for like individual project access, very easy. What is hard is for bulk operations, and it starts with simple things like list all the projects that a user has access to. Filtering all of these permissions across all the projects gets very, very expensive, especially if you have like thousands or tens of thousands or hundreds of thousands of projects. So this really needs careful planning, careful tuning. I mentioned the project model being kind of a problem because now you need to assign access to every single project version because the version is part of the project entity here. This really makes it hard to scale. If every single time your team adds a new project version, you have to go into the settings, assign the team access. That will not work at larger scale, right? So ideally what we want is we want to decouple the concept of projects from project versions. And that would be helpful not only for access control here, but also for notification rules or policies. So you don't have to repeat the same associations every single time you add a new project version. And decoupling like projects from their individual versions would help a lot in this. Yeah, right. So again, for this, there's a GitHub issue. You are very, very welcome to join the discussion. This is still something to be done. We are still working on the model. We are still evaluating if this is feasible or not. And then like just a few more words on the project level permissions. How it really should be working is, can a given user view components? This is a check that we want to have. What we don't want anymore is the separation between having a permission and having project access. Ideally, a user having access to or the permission to view components in a project should be sufficient for this model. On a similar vein, some checks only need a very specific access level, right? But if you have more access than what is required, that's also fine. And this ends up being more like an implementation detail, but this is ideally what we want and what we want to use in queries that the backend performs. Again, still working on the table design for this. That's a very large issue. Again, you're very, very welcome to join in. There are lots of comments on this already, and we're still flushing it out how exactly we want to implement this. Jumping over to non-functional changes, starting out with the database. As you can probably tell by the background image, we are going all in on Postgres. The lowest supported version as of now is version 13, and we might raise it to version 14 before we go GA with Dependency-Track version 5. That just has to do with whether or not we use a specific feature that only has been introduced in 14. That's still to be figured out. The support for H2, MySQL, MS SQL is being dropped. And that just leads to a drastic reduction in testing effort for us. At the moment, for releases for Dependency-Track version 4, we have to literally test all the migrations with all the various database systems. We have to test all the queries with all those database systems, and we still, like, despite excessive testing, still stuff slips through, and it's just not feasible in the long term. It also gives us more opportunities for optimization. If we only have to focus on one database management system, we can be much more thorough with our optimization attempts. We also switched to a more reliable and changelog-based migration system, which just means migrations will be more reliable. At the moment in version 4, I think it's debatable if they are reliable. If something breaks, it's not always easy to recover from that. You will also be able to use a separate set of credentials for migrations. So if, for example, your operations team simply does not allow you to use higher level permissions on your application database access, you can separate those concerns, give separate credentials to the migration stuff, and make your operations team happy. To facilitate all of this, we have switched all our tests to always run against the lowest supported Postgres version. In version 4, we ran our tests against H2, like an in-memory database, which meant that the value of the tests wasn't quite there because it could still fail due to some specific failures in MS SQL, Postgres, or MySQL. But now we test against Postgres. The assurance of stuff actually working in production is a lot higher now. We also resolved various schema inconsistencies already, and we are continuing to do it. For the migration, we said this before, but there will be tooling that helps you migrate from version 4 to version 5. That includes if you currently use something other than Postgres. So if you use MS SQL, there will be tooling to migrate your current data. Still, when you are deploying new instances of version 4 at the moment, please use Postgres. Do not deploy something else because that will just make your migration harder. Also, because we started introducing basic telemetry in the last version 4 release, we now have a rough idea over how the distribution of database management systems among the community is. So for those who have already upgraded past version 4.13, we can already tell that most of you are using Postgres, which is very good news for us. We will see how this evolves. Certainly, the number of H2 installations is a little bit concerning, I'm going to be honest. But the high usage of Postgres is reassuring for this step. Moving on to something that I just called async processing for lack of better words. And this really just involves async processing, queuing tasks that cannot be done synchronously whenever you interact with the API, right? And how it currently works in Dependency-Track version 4 is there is an in-memory message queue where a thread pool or a pool of threads pulls tasks from and executes them pretty much as soon as they're available. So this is happening out of order. It's entirely in memory, so it's not durable. If the service goes down, all the queued things are gone, which is problematic. You have no ordering guarantees, so concurrency control is a problem. So this is the situation that we started with. What we currently have and what we migrated to is basically using Apache Kafka as a backbone, using it for communication between services. You can also tell here we split certain functionality out in separate services, separate from the API server. This includes vulnerability analysis, notification publishing, repository metadata analysis, like fetching the latest version from repositories. And the idea was really to have high volume asynchronous processing be extracted from the API server so it has more capacity to handle other stuff, for example, accepting bombs that you upload, handling user requests, etc. Now, just reiterating on the original intent of introducing Kafka, we wanted this to be an event-driven system, essentially. Again, reduce load from the API server, offload asynchronous processing as much as possible, and to reduce stress from the database further, we were planning to use stream processing techniques. So in Kafka, you can essentially join streams or do stateful processing without relying on a database, how do I say it in English? On a normal database, on a relational database. You can use in-memory or file-based key value stores for this, which, while it's not super optimal to have a file-based database, it relieves stress from the main database. So this was the intention. We also wanted to encourage loose coupling. There was this idea of polyglot application, basically, so the community could come in and contribute a service written in Go, whereas the main application is written in Java, right? Having loose coupling would have helped with this. We wanted to enable horizontal scaling of services, which is self-explanatory, I think. And one nice property of Kafka is it has partition level ordering. So in Kafka, we have topics. Topics are split into partitions, and within a partition, you get the guarantee that messages with the same key end up in the same partition, which is very convenient for avoiding locking. If the same consumer always gets the same message or messages for the same key, and if the key is picked well enough, addresses the same resource, you can avoid using logs because you can be sure only this specific consumer instance is processing events or messages for this key. Also, we evaluated other like message buses or messaging systems, and it seemed like Apache Kafka is the largest ecosystem among them all. It being an Apache project obviously helps, but there was a broad offering in cloud services. Self-hosting also got a lot more approachable. Kafka has dropped the Zookeeper requirement in recent versions. There are now various different implementations of the Kafka protocol, including Red Panda, Buff Stream, I think it's called, Warp Stream, and a lot more. So you don't really have to run this heavy piece of infrastructure anymore if you don't want to. But you can also still get it from cloud services via managed offerings. So this was making it kind of attractive. What went well with this architecture, I would say? The loose coupling was or is very convenient for deployments. Not having to worry about availability of services while you do a new deployment is very nice. The client libraries for Kafka are very capable, easy to integrate. The throughput of the system is amazing. You can publish lots of messages at once in a short period of time. You can consume a lot of messages in a short period of time, especially if you then couple this with batch consumption. So you pull in hundreds, maybe thousands of messages at once, do some slight pre-processing, and then flush it to the database as an example. So this was really great, or is really great. The ordering guarantees I mentioned, they were helpful for avoiding locking, but they're also perfect for caching, basically for the same reasons. If you always have the same message key ending up at the same consumer, you can use local caches. You don't have to use complex cache and validation strategies or host a centralized caching server. And it's a perfect medium to publish notifications on. Per default in Dependency-Track version 4, you can use emails as the destination, webhooks, and I think a few more. But what all of them have in common is they are not reliable. The email server might be down, or like the destination of your webhooks might be down, might be slow in processing your requests. And with Kafka, basically, as soon as you publish your notification, you get an acknowledgement back. You can be sure this will eventually be delivered, even if the service consuming this message is currently down or unavailable or whatever. So this was really good. But in building this, we kind of realized over time that actually we're kind of dealing with workflows. So this is an example here of the BOM processing workflow. What happens when you upload a BOM? We first ingest the BOM itself. Then in parallel, ideally, we do vulnerability analysis, repository metadata analysis. After these two steps are done, we do policy evaluation, because policy evaluation might rely on results from the previous steps. And after that, we do a metrics update, because that, again, depends on results from policy evaluation. The thing about this workflow is that clients need to know about the progress or if it failed. If you think about the CI/CD use case, you have like a publish to dependency track step in your CI pipeline, for example. You want to know if this process succeeded or not, like if your project is being analyzed or not. In version 4 of Dependency-Track, all you get is a correlation token as a response to a BOM upload. And with that token, you can then ask for, hey, are you still processing this? And in response, you get true or false back, which is not all too helpful because you don't know, did it fail? Did it succeed? You don't know. Also, the administrators need more visibility into this. It is very hard with an event-driven approach, for lack of better words, to piece together all these various kinds of information when really you care about the whole workflow end to end. Also, each of these steps can fail individually and might need retrying. And this was very hard to model as a whole. So what we end up doing as an intermediary step is we introduced a new database table to track the status of a workflow. And this was done by persisting steps of a workflow, including their current status, when it was started, when it was updated, and also if it failed, there was failure information. How this was being used in practice is, you can see here, when the client uploads a BOM, the workflow and all of its steps would be created in the database with a pending status. Then an event would be dispatched, and while processing the event, we would update this table whenever we completed a step, right? So when we start a step, for example, the BOM consumption step, if we start to parse the BOM, we update the step with a started add date. Once that is completed, we update it with, hey, I completed this, and so on and so forth. What made this kind of impractical is that there's no orchestrator, right? The code itself, the logic of event processing itself needs to know it's part of a workflow. It needs to know I need to update workflow steps. And this needs to be repeated across all of the steps. All of them have to know, hey, I'm part of a workflow here, I need to do something. And they also need to know what to trigger next. So each step has to know what is the next step? What do I need to trigger now? Because there's no overarching orchestrator that knows about the full workflow. This also has the negative side effect of many small database transactions. Just think about uploading multiple bombs, and each bomb processing step like hammers the database with update step, update step, update step, update step. So those were the downsides. But as an upside, we could offer users a REST API endpoint, which could also be used for front-end interactions, where you could then see all the steps, which one succeeded, which one failed, and possibly also why it failed. In this case, you can see the bomb processing step failed because it failed to acquire a database connection. And then as a result, we canceled all the follow-up steps, in this case, the vulnerability analysis. But it's not only workflows, it's also complex or more complex workflows. Here you can see it's not only vulnerability analysis, it's vulnerability analysis with the internal analyzer, with OSS index, with Sneak. And this might be dependent on which analyzer you have enabled, right? You cannot pre-compute or predefine all of these steps that are necessary because the user might just have OSS index disabled. And this is just a very basic example of what you might want to do and what was not easy to achieve with the model that we had built. Also, as I said before, every single step can fail. Bomb ingestion can fail, OSS index might be slow to respond. The application might crash between policy evaluation and metrics update, or we just do a normal planned server restart, right? If we are in the process of executing this workflow, we want the application to pick it back up if it starts again, or other instances of the application to pick it up where others have left. Also, like, you need to know what is happening, right? Even if the workflow is currently running, you want to know where it is currently. And if it is failing, why is it failing? And one thing we learned over time is we cannot expect users to have log access because in many organizations, log access is restricted. Only the operations team has access. And then the poor analysts or developers sit there and don't know what is happening. So really, this needs to be exposed to users. But it gets even more complicated because the bomb processing workflow actually consists of multiple sub-workflows, if you will. Namely the project, it's just called project analysis workflow here. And this is what is doing the analysis, the vulnerability analysis, the policy evaluation, and the metrics update. Splitting this up is important because Dependency-Track also performs this analysis on a recurring basis, right? Every day, or at least daily, every single project is supposed to be analyzed for new vulnerabilities. Policies are supposed to be evaluated, and metrics are supposed to be updated. So this is there's not one workflow that performs these options. It is the workflows, or these actions might be triggered through multiple occasions. There's also a fancy reanalyze button in the UI, so users can request a new analysis on their own. So with all that said, you really want to prevent the same workflow for the same project to be executed at the same time, because that could cause race conditions, inconsistent data, and so on and so forth. What is limiting in the way that we built the workflow system before is there was no way to control concurrency of the entire workflow, right? Individual steps, maybe, but the entire workflow, controlling concurrency was simply not possible, at least not without additional bookkeeping and logging and whatever else. So this really wasn't leading anywhere good, so to speak. Now, why retroactively we think Kafka wasn't really the right choice? And these are like not really necessarily related to what I've mentioned before with the workflows, but there's this risk of having dual writes where you do a database operation and then send an event to Kafka, right? You want to inform about what you just did, be it a notification or just an event to inform other services. And there is this risk of writing something to the database, but then the Kafka publishing failing, or the other way around. And this is just what you would call dual writes. You get inconsistent data quite fast because it is not possible to share a transaction between database and Kafka. Non-blocking retries for Kafka were hard to implement. There are services and libraries, and there are ways to implement them, but it's very hard. There's no support for prioritization in Kafka topics. You just append to a log, you consume from the log, but there's no way to consume higher priority items first. There are message size limitations. Per default, it's 1 megabyte per message in Kafka. Some organizations, we have learned, do not allow to increase this. So this was a problem. This then forces you to use many, many small messages, which doesn't really work well with certain workflows or with certain processing objectives. Sometimes you want to process an entire bomb, for example. Sometimes you want to communicate all the vulnerabilities in a project. And if that project is large, has many vulnerabilities, it is easy to run into size constraints. Observability requires specific tooling. Once you publish something to Kafka, it becomes kind of a black box. You cannot inspect what kind of data is in the topic unless you have special monitoring tools, which you cannot integrate into your application. Going back to the workflows, it is very hard to reason about end-to-end processes. We further learned that there are constraints in user environments. So some users were able to deploy Kafka, but they were not allowed to use certain features of Kafka. Kafka does support transactions, for example, and it does support compacted topics, but some users were not allowed to use it by their operations team, which was fun to learn about. I also mentioned there are multiple implementations of Kafka. Not all of them support all the features. For example, transactions. This was a challenge as well. Topic management is kind of a hot mess. It is much harder to do than database migrations. And the community support would also be hard to achieve. It's something that we learned over time. So we have an architecture decision record to drop Kafka support. I'm speeding up a little bit because I realize we're already quite far into the meeting, sorry. So yeah, if you want to learn more about why we are dropping Kafka, why we decided for this, you can learn about this in this decision record. It's all a little bit more detailed. So what are we doing instead? We are going to switch from a choreography to an orchestration way of handling processing, which just means there will be an orchestration layer that then decides what to run, what to retry, what to run next, etc. And we will use a model that is called durable execution. Maybe you heard of it, maybe not. I will hopefully be able to show a demo in a few moments. Boils down to, for us, orchestrations or workflows are just normal code. There's no YAML definition, no JSON, DSL, or whatever, what you would see in the wild. It's just normal code. The solution is heavily inspired by Microsoft's durable task framework, which inspired Cadence, which inspired Temporal, which are like central workflow orchestration services that were unfortunately too big to integrate into Dependency-Track. We developed an engine that is embedded, so there are no additional services to deploy. The tasks are being executed in lightweight virtual threads, which are new as of Java 21. So the memory footprint will be lower. The messages being passed between workflows and workflow steps are using protobuf. So efficiency realization, backward compatibility checks, etc., are all there. This whole implementation is optimized for Postgres. It is optimized for throughput, which mainly means almost all database interactions are batched. And we use buffering of persistence operations to improve the chance of batching happening, essentially. And this whole thing can be configured to use a separate database, so it doesn't have to run with the main database of Dependency-Track. If you are running a larger instance, you can just point it to a separate server, but you don't have to. And simple deployments can just use one database, one Dependency-Track service, and done. There's no additional dependency there. Again, there's also a architecture decision record for like what we considered as other alternatives and why we ended up in this with this decision. Now, hopefully, I can do a quick demo now of how this would look like in practice. So I have a demo spun up here. There will be a new window or a new view in the UI called Workflow Runs. What I will do now is I will upload a bunch of bombs, 50. And while this is going on, you can see this being populated here. if I click on one of them, zoom out a little bit here, you can see there's a history here. And the history just is a log of what the workflow is doing. You can see all the steps that are being executed. You can see the inputs. You can see the outputs. I also added a failure injection here. So ideally, we should find a workflow that failed or a step that failed in a moment. But yeah, you can see the input here, for example, the project input that was given, the BOM file that was being uploaded. You can see individual steps being scheduled, which are just called activities here. And also sub-workflows being scheduled. Now, this all looks still rough. It's still a proof of concept, but this is the process BOM upload workflow that I showed earlier in the graphic, right? And I also mentioned it should run a sub-workflow, which I can call here. So this is the accompanying analyze project workflow. If we scroll all the way down, again, same thing. We see when it was scheduled, when it was started, when it scheduled the analyze project vulnerabilities activity for internal analyzer, for index analyzer. We see when it completed. We can see the output. In this case, it just writes to a VDR file, just an implementation detail at the moment. Now let's see, did it fail anywhere? It did not. Maybe we find another one. But you can also see there's a link here back to the project. You can, or we can assign labels to workflows. In this case, we labeled it with the project UUID, which then allows you to just jump to the project that is being the subject of the workflow. And then on top of that, ideally in the project view itself, there would be a view that just lists, hey, here are the workflows that ran for this project. And when you, let's say, trigger a reanalysis via the UI, it would also show the progress, and it would also show if you triggered something before. If it failed, it would show the failure here. And by using this like workflow implementation, we get all these options, and it's much easier to achieve. Now let's just quickly go back here. Let's see something. Okay, so this one failed. Scheduled, failed. So here an activity has failed. We can even see the stack trace. The formatting will probably be different in the future, but you can see here my fault injecting activity has triggered. So it has bubbled up to the workflow. The workflow then decided, hey, I can reschedule this. This is retryable. So it retried it. It failed again, but then it also completed normally. And yeah, some failures are just not recoverable. They are then just terminal. So in this case, at the very top, probably, yeah. So this activity here failed terminally. So then the entire workflow failed as well. Again, this will see lots of improvements for like the UI, but the information is all there. It's just a matter of presenting it nicely now. You will also have the option to pause, to resume, and to cancel workflows from the UI, and a lot more. And going back to the presentation. On a related note, because we are getting rid of Kafka, there will also be a need to replace the notification publishing destination with something else. We have a plan for this. There's also an ADR for it. There's a POC implementation already that that you can look at. And it will also be based on Postgres. Melba, you're raising your hand.
Yes, time check. You have 7 minutes left, and there's one question in the chat.
Oh no, should we do the question now?
I don't know how many more slides you have, but the question is fairly straightforward. I was not able to answer it, unfortunately. If I am already using Postgres, will/can the update be done in place, or do I need to set up a new database?
I guess that depends on how we implement the migration. Off the top of my head, I would say you probably would want a separate database for this, just for the case of the migration failing for whatever reason. You do not want to destroy your existing data. That would be advisable, I think. I hope that answers your question. Okay, so I'm trying to press on the the pedal here. So just to summarize, Dependency-Track version 5 will not depend on Kafka as originally planned. The async processing will become more resilient and failure-proof essentially, and most asynchronous processes will be observable from the UI. Oh boy, data retention. So there's this, we track time series data in Dependency-Track, and these metrics tables can become quite large, especially if you have many, many projects. Every single project and every single component produces at least one metrics data point per day, at least. So this can grow quite large. So we need a method to restrict this growth from becoming too much. The problem with Postgres is if you delete a row in your database, it's not actually deleted, it is just marked as deleted. So then auto vacuum needs to come in and actually remove the column later. So deleting like millions of records in a single go every day is too heavy on the database, and it's like you cannot. It's not a good approach because it causes table loads, I/O spikes, because every single delete needs to be written to the write-ahead log of Postgres. And if you have replication set up, every single delete needs to be replicated over the network. So what we end up doing, or what we are doing now, is we are partitioning the metrics tables, which is a feature natively supported by Postgres. Essentially, every single day would get its own partition. And to enforce retention, we would just drop the partition of a single day. Which is like doesn't cause bloat, doesn't cause I/O spikes, and it's cheap on replication because Postgres only has to communicate, hey, your table was dropped, and that's all. The retention span will be configurable. It will be defaulting to 90 days, and the partition management is entirely taken care of by Dependency-Track, not by Postgres. We will follow the same approach for workflows. So if a workflow completes, we will keep it around for a while. That will also be configurable. And we will also use partitioning to efficiently remove all data. Again, link back to the issue where we are currently implementing this. Almost done. So for contributors, a few things to keep in mind. We have started using architecture decision records. You have seen me link them previously. If we are making larger changes now, we write a decision record for it, just for this for these things to be traceable when we come back to it later. So if you are planning to contribute something larger, you will have to write an architecture decision record, and we will review it and contribute on it. For running tests locally, you will need Docker or Postman. That has just to do with our heavy use of test containers. I mentioned before, we are testing against Postgres all the time. And test containers are the way to run local Postgres instances that are temporary and can be discarded swiftly. So that is needed. Also, if you are contributing to the code base at the moment, you will have to prepare for frequent rebasing because there's quite a lot of activity on it right now, just so you're warned. Finally, what's next? We are going to complete the transition away from Kafka as soon as possible. And that really has to do with most other changes being doable after a version 5 release. Really, we want to get away from having to maintain version 4 and version 5 in parallel and just splitting our time between them, having to port changes between them. That will not be sustainable for a long time. So best get this over with sooner than later. We will also flesh out the access control improvements, and there is a lot of help on this from the community, which I'm very, very thankful for. So really hope we're getting something good here. This might cause breaking changes, which is why we want to do this before the version 5 GA point in time. And of course, this will be part of the migration tooling for version 4 to version 5. That's it. Almost a point landing, 2 minutes to go.
So there is one more question in the chat. It seems that we haven't had a release version of Hyades for quite some time. Relying on snapshot builds may not be ideal from a security and stability standpoint. Would it be possible to consider cutting a tag/release on a monthly or quarterly basis?
Yes, definitely. So we didn't do it in the past weeks or months just because there were so many changes, and there wasn't really a point to cutting a release if you cannot guarantee at least a little bit of stability on it, right? But yes, we can do that, and we should aim for that as well. Yep.
And There's no more questions in the chat. If somebody wants to come off mute and ask a question, feel free.
Hey guys, thank you very much. Just a quick one regarding the VEX. I had a similar case of getting overwhelmed by a lot of vulnerabilities for different components. I don't care, they are not relevant. And I introduced this concept of meta VEX using a cell expression. In this case, basically, I'm able to say whatever is coming from a container, and it is this package URL, or it is just this wildcard of package URL like Git or OpenSSL or curl, just ignore it. That is going to add one entry in one place. It's going to ignore everything, but I don't have to write single VEX everywhere. Those VEX, they will be produced when you fetch the VEX. Then it's going to be created at runtime based on the exception. Is it something that you might want to investigate? I don't know. Or do we have it already?
Can you summarize what you? Sorry, I didn't quite understand what the process would be.
A meta VEX in a way that is a common expression exactly like this that will allow me to have one exception in one place. And in the moment that you need to fetch a VEX file for any project, that VEX file is not there, but will be produced at runtime based on the exception. So you don't have to go and produce singular VEX files. It's just a render of an exception. Is it something that is working like that? Or how do we manage the VEX with the vulnerability police that you have introduced?
Okay, maybe that is just a confusion. So I use the VEX mainly to explain like the concept of what this is actually doing, but VEX is not actually involved. So you would define this once, it would populate your audit trail in the findings view for as many findings and projects that match the condition that you define. But there's no VEX fetching or VEX files involved at all.
Right, but this is the exception. And so the question is, I have the policy that is ignoring if I try to fetch the VEX for a specific project.
Yeah.
What do I get?
If you fetch the VEX for a specific project, you mean export the VEX from the UI or?
Yeah.
You would get the same as if you would do this manually. So.
Oh, fantastic.
The action that,
thank you.
Okay, yeah. Just to formulate this out, the actions that you define here in the analysis part, they also populate the audit trail in the UI, in the backend. When you export a VEX from your project, it will also have like the state, the details, etc., that you define here. So you can share the VEX that Dependency-Track generates based on this data. Yeah.
Fantastic. Top class. Thank you very much.
So with that, we are 2 minutes over, Nicholas. So thanks everyone for joining. If you have further questions, by all means, I think you know where to reach Nicholas and the rest of us. I will post it in the chat, that project for Dependency-Track. There's a GitHub. There's so many ways to reach us. So yeah, anything else, Nicholas?
No, that's all. Thanks for joining.
Thanks, everyone.
Thanks all.